Let's now discuss configuring vSphere high availability. When we configure high availability, we create a cluster, configure the cluster, and then add ESXi hosts. To create a cluster, we go to our data center in the vSphere web client. We right-click on the data center and select New Cluster. We give the cluster a name such as Cluster 1. I will not enable DRS, we will do that in the next chapter, but I will enable vSphere high availability. I will click on that checkbox and it expands the entire window, and you can see I have now turned vSphere high availability on. You see an item here that says host monitoring, and we can select the checkbox that says enable host monitoring. This is something we definitely want to do because the whole purpose of high availability is to monitor the hosts in the event that they crash. Now, another item to look at under host monitoring is what they call admission control and admission control status. Admission control will prevent powering on virtual machines that violate availability constraints. If we enable admission control, then if there are not sufficient resources for fault tolerance, then no new virtual machines will start. And here's the example. We have a virtual machine which takes 4 gig of RAM on one ESXi host. There must be 4 gig of RAM free on another ESXi host so that virtual machine can fail over in the event that the first ESXi host crashes. If there is not 4 gig free on another host, then that virtual machine will not start. The idea here is if the virtual machine is not going to be protected by high availability, then we don't want that machine to start at all. That's the purpose of admission control. So I will certainly select the checkbox that says enable admission control. If we look at the admission control policy, we see that we can specify the type of the policy that admission control should enforce. And the default is host failures that the cluster tolerates. What that means is that if we have 3 ESXi hosts, the third ESXi host must be free to provide failover capacity. Of course, the problem with that is it requires that you have an extra ESXi host, and a lot of people don't have ESXi hosts just sitting around. So what we can do is we can select percentage of cluster resources reserved as failover spare capacity. If I select that radio button, the default is 25%, but I can change the reserved failover CPU capacity to, for example, 50%. And under reserved failover memory capacity, I could configure that to, for example, 50%. So under admission control policy, if you set it to 50%, then only 50% of all virtual machines will be covered. Here's the example. You have 3 ESXi hosts and 2 of them are running at 50% capacity. So the third host must have 50% free RAM to provide failover capacity. And of course, you can see in this scenario, not all of the virtual machines will be protected. Only 50% of them will be. This is called reserve percentage of cluster resources as failover spare capacity. And then under VM monitoring, well, of course we want to monitor VMs because if a virtual machine crashes, we want to be able to restart that virtual machine. So I will enable virtual machine monitoring. Now the next thing to do is to add hosts to the cluster. So I will go to my first host and right-click on it and select Move To, and I will move it to cluster 1, followed by OK. Go to my second host, right-click, select Move To, move it to cluster 1, followed by OK. And then go to the third host, select Move To, select cluster 1, followed by OK. Now if I expand this cluster, I can see there are 3 ESXi hosts in this cluster, and there are multiple virtual machines. If I click on the Monitor tab, I can see how hard this cluster is working, and it's not working hard at all. The cluster CPU utilization is only at about 5 or 10%, and the memory utilization is only at about 5 or 10%. So this cluster is not working very hard at all. Now let's discuss EVC Enhanced vSphere Compatibility. If we go to Intel's developer zone and we look at the Intel architecture and processor identification, we can see that different microprocessor architectures have different code names. For example, the current fastest microchannel microarchitecture is called Ivy Bridge, followed by Sandy Bridge, and then Marrom is slower than those other two. So to ensure compatibility between ESXi hosts with different types of microprocessors, then we enable enhanced vSphere compatibility. To enable enhanced vSphere compatibility, we click on the Manage tab and we click on VMware EVC followed by Edit. You can see that EVC is currently disabled. I will enable it for Intel hosts, and I will select the drop-down and I will select the Marrom processor. So now we can see this applies the baseline feature set of Marrom generation processors to all hosts in the cluster. Hosts with the following processor types will be permitted to enter the cluster. Certainly Marrom, Penryn, Nehalem, and Westmere, as well as Sandy Bridge and Ivy Bridge, and all future Intel processors. Now we can see that EVC has been enabled. Now let's discuss the restart order. If we have set our emission control policy to 50%, then only 50% of all virtual machines will be covered. And the question is, which virtual machines will be covered by high availability? And the answer is the restart order. If we want certain virtual machines to boot before other virtual machines, then we change the restart order to high. To change the restart order, we select the Manage tab, and under the Settings button, we select VM Overrides. Under VM Overrides, we click on Add, and then we click on the green plus button, and then we add the virtual machines which we want to start before all other virtual machines, and in this case that will be the DNS server and the DHCP server. And then under Restart Priority, I will give those two virtual machines a higher restart priority. So now if the ESXi host crashes and not all virtual machines will have enough CPU resources to restart, we can guarantee that the DHCP server and the DNS server will start first. Now let's discuss monitoring sensitivity and the migration threshold, which can be set to high or low. And this introduces the concept of heartbeat. A heartbeat is a signal sent from one ESXi host to the other. And if the second ESXi host does not receive a heartbeat from the first ESXi host, then that means that the first ESXi host has died. So then the virtual machines will be started on another ESXi host. The question is, how long does the controlling host wait if it hasn't received any heartbeats, until it decides that the first ESXi host has died. And this introduces the subject of monitoring sensitivity and migration threshold. If we select the Manage button, and then if we scroll down, we can see that the VM monitoring sensitivity is currently set to high. So that means if the first ESXi host does not hear from the second ESXi host in 30 minutes, then it assumes that that host has crashed and starts the virtual machines on another ESXi host. However, if we set that setting to low, then if the first ESXi host doesn't hear from the second ESXi host at 120 seconds, then it restarts the virtual machines on another ESXi host. So why should you set it to low versus high? If you set the migration threshold to high, then there will be a quicker response to a failed ESXi host. But the disadvantage is this might trigger due to a network latency, meaning that the host didn't fail at all, it was just a slow network. And this is what we call a false positive. On the other hand, if we set the migration threshold to low, then there's a lower chance of a false positive, but it will take longer to recover from a failed ESXi host. Here at the Community College of Baltimore County, we set it to high because we have pretty reliable networks. The main point is that vSphere High Availability provides automated failover, meaning if one host fails, then the virtual machines are loaded into memory of another ESXi host. And this concludes our section on configuring high